All right, we're going to start section 5.5. We're going to do our last factoring technique of sum of cubes and difference of cubes. So you remember that there's 7 steps anytime we're asked to factor any sort of problem. Make sure it's in order, look for a GCF, and then look to see how many terms there are. Remember, if there's 2 terms, you're going to try to do a difference of squares. We talked about that in the last section. If it's not a difference of squares, then maybe it's either a sum or difference of cubes. That's what we're going to talk about in this section today. If it's 3 terms, then it's either going to be basic factor or bottoms up. Remember, bottoms up if there's a number in front that you can't GCF out other than a 1. And if there's 4 terms, remember we're going to factor using a technique called grouping. Hopefully you've practiced the other techniques that when we add to cubes, you're already comfortable with the other techniques because eventually they're going to be all mixed up. So let's go ahead and talk about cubes. In order for it to be a sum or difference of cubes factoring, there has to be 2 terms. The coefficients or the numbers must be perfect cubes this time instead of squares like when we did difference of squares. For example, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. They have to be perfect cubes so that we can break them down with cubes. And then if there's any exponents on our variables, they need to be divided now by 3. Before, remember they were divided by 2, but for cubes they need to be divisible by 3. So when we're factoring cubes, we're going to rewrite the terms as cubes. We're either going to cube root the coefficients or the numbers, and then we're going to divide our exponents by 3, and then we're going to factor using our formulas. So we need to make sure that we know these formulas, that we can find patterns to help us remember these formulas, because these are formulas that you'll need to know from now on. You will not be able to use a note card or a formula sheet, so make sure you know these formulas. Now, remember before when we did squares, there's only a difference of squares. There's no such thing as sum of squares. But for cubes, there is. You can do a difference of cubes or a sum of cubes, depending on the sign in between. It'll work for either one. Now, if my problem is a difference of cubes, we need to have a base that is cubed minus another base that is cubed. And I always start with my parentheses. I'm going to do a small parenthesis, and then I'm going to do a bigger set of parentheses. Then I'm going to fill in my signs. It's always the same sign, the opposite sign, and then a plus sign in the back. Same, opposite, always positive. Some students remember the initials for SOAP. Same, opposite, always positive. From here, all we have to do then is fill in the blanks. The first blank is going to be my first term, so in this case, x. My second space is going to be my second term, so in this case, y. Now it's going to be my first term squared, so x times x is x squared. It's going to be the 2 terms multiplied together, so x times y. And then it's going to be the last term multiplied by himself, or squared, so y squared. It would work the same way if it were a plus sign in between. If I have a base cubed and another base cube, then I can factor it using a sum of cubes formula. Small parenthesis, bigger parenthesis, same, opposite, always positive with your signs. And then you just have to fill in the terms. So it would be my first term, my second term, my first term times itself, the 2 terms times each other, and my last term times itself. So it looks like that. So depending on your problem will depend on which formula you use. Let me show you some examples with numbers. Example number 1 asks us to factor. So still make sure you're following the 7 steps. Is it in order? Is there a GCF? And on this one it doesn't look like there is. And how many terms are there? Well, in this problem there are 2 terms. 1, it's not a subtraction sign. 2, it's not divisible by 2. So I know it's not a difference of squares. So let's try cubes. Now, in order to be a sum or difference of cubes, remember it has to be, each base has to be something cubed. In this case, the only thing that I see cubed is the x. So I have to somehow rewrite 27 so that it is in cube form instead. So what's the cube root of 27? What times what times what? What cubed gives me 27? 3, right? And so instead of calling it 27, I'm going to call it 3 cubed. So that way it looks like the formula. I have a base cubed plus another base that's cubed. And so my bases, my terms, are the x and the 3 this time. So here we go. Let's start with our little parenthesis. Let's start with our bigger parenthesis. Let's do our signs first. Same, opposite, always positive. So a plus sign, a minus sign, then a plus sign. And then let's fill in the spaces. So it's my first term which is x, my second term, which is 3, my first term times itself, so x times x, or we can say x squared, my two terms multiplied together, so x times 3, or can we say 3x, and then my last term times itself, so 3 times 3, or we're going to say 9 to make it look nice. This would be the factored version of my original problem. If you were to distribute the x through and distribute the 3 through and combine all your like terms, I promise you should end up with just an x cubed plus 27. Try it if you want to make sure. But this is the factored version of my original with a sum of cubes. Let's do a difference of cubes. Look at B. It's in order, there's no GCF, and I see two terms. Now I see a subtraction sign, so it might be a squares problem. But an 8 isn't a perfect square, and an m cubed isn't divisible by 2. So I know it's not a difference of squares, but let's see if it's a difference of cubes. But remember, in order to be a difference of cubes, we have to have two bases that are cubed. And right now, the only thing that I see cubed is the m. So I have an m cubed. But what is 8 equivalent to as its cube? So what cubed gives me 8? What times what is the same thing as 8? 2, right? And so now that I have both of my bases as cubes, I can use my cube formula and I can factor it. So I have my little parenthesis, my big parenthesis, my signs go first, so same, opposite, always positive. And now let's fill in the pieces. I have my first term, which is m, my second term, which is 2, my m times m squared, my 2 times n, or 2m, and then my 2 times 2, which is 4. So this would be the factored version of m cubed minus 8. If you're not sure, distribute it through. So distribute the m through, and that's what I did here in the red. Distribute the 2 through, and combine like terms. You'll notice that you have left only an m cubed minus 8, which is what you started with. So we know we have the same, or the correct, factored version.